it's tedious. It's incredibly tedious, right? So if you're not enjoying this process, it's probably because it's boring, not because it's difficult. All right. So that's a nice motivating speech, right? So we have two pieces to this function, right? A piecewise function is exactly what it sounds like. Is that the blurb I wrote? No, I used to write that blurb in there. It's exactly what it sounds like. It's a graph that's plotted in pieces, right? What we're saying, it's really more like a conditional graph. We're saying that under some set of circumstances, we're plotting one piece, and then under other sets of circumstances, we're plotting other pieces. All right, so we have two pieces here. This one, and this one. But what we do is we write it as two separate equations, y equals x squared plus 2. And again, that's only if x is less than 1. And then we have y equals 3x minus 5. And that's only if the values of x are between 1 and 3. All right. So what we're going to do is create a table of values, and you can use Desmos to support your work here. Let me just save this real quick. I'll try to make like a nice calculator out of that, but I don't want to lose it. All right, so you can use Desmos to support your work, but ultimately you'll need to be able to create this by hand. All right, so we're looking at values of x that must be less than 1. So what I would do is type in y equals x squared, equals x squared plus 2. But only plot the part of the graph where the x values are less than 1. All right, so all of these values are less than 1. All of these values are less than 1 until we get to this location here. Now it's equal to 1, so we would stop. All right, so what I want to do is I want to grab some points from this. So there's two ways to do that. One, the way I'm doing it here, just drag along and grab some points, but you see there's a lot of decimals. You could also eyeball it. I mean, we got a nice clean one there at 0, 2. Okay. But sometimes we don't even want to do that much thinking. If you hit that little gear icon, you see the table icon, tap that and it'll convert your equation into a table of values.
Wait, can you show how you made the table again?
Yes.
Yeah, I didn't see the gear icon.
So this is your gear icon. Tap on that and you see an image of a table. Tap on that and it converts it over. And so now we have a table of values, and all I would do is just jot this down. So I got -2, -1, 0, and I would stop at 1. Now, we need values that are less than 1. So you'd say, well, why would I put a 1 there then? What we do is if we want to get close to a value but not actually touch it on a graph, we plot it with an open circle. All right. So any value that involves a less than, so only for less than or greater than. All right, so from this table, I'll pull the -2, 6, the -1, 3, the 0, 2, and the 1, 3. But that very last point I plot with an open circle. Now, I'm going to create the table for the next equation before I start plotting anything, because I don't know how things are going to work scale-wise. So I want to make sure I tackle this the right way. All right, so again, just like we did for the previous one, you type in your equation, y equals, this time it's 3x minus 5. it'll plot the line. We don't want the whole thing. We only want the part of it that's between the x values of 1 and 3. So I'll convert it over to a table. So I hit the gear icon, the table icon. Now you see here, I don't have quite enough table, but that's okay. We're going to make it work. So the x and y values that I care about start at 1 and end at 3. So 1, 2, and 3. 1 has a -2. 2 has a 1, but you see that there's no 3 there. The default setting for Desmos is to go from -2 to 2. If you want anything more than that, you got to type it in yourself. So what I would do is tap on that next cell and type in a 3, and it'll spit out the 4. So now I know what the corresponding value is. So you just put the number in yourself. You do it manually, right? Well, Desmos manually, you know. So these are reasonable values. I won't need to scale the graph here. So I'm gonna put my x and y axes in. Label them up. So I'm gonna plot -2, 6. I'm gonna plot -1, 3. 0, 2, and then 1, 3 I plot with an open circle. And again, that just means that we're going to get very, very close to the x value of 1, but we're never actually going to touch it. That's what this symbol means. All right. Now, just because we stopped our table at -2 doesn't mean that this graph doesn't continue. It's all values less than 1. So -2, -3, -100,000, -a bazillion, you know. So when we draw this graph, we want to take that into account by throwing on an arrow at the end to indicate that it goes on forever. That's a shaky graph. I think I can do better. All right, so that's one piece of the graph, right? Emphasizing the piece part of it because it is a piecewise function. The other piece, we would plot -1, I'm sorry, 1, -2, 2, 1, and 3, 4. Now these are ordinary points. Again, the only time you need to worry about open circles is when you're dealing with greater than or less than symbols. Everything else gets plotted with solid points. All right. Now this starts at 1 and ends at 3. Does not go on forever. So I don't continue the trend. I just connect these dots and call it a day. All right. And so that's a piecewise graph. So you're graphing it in pieces, just one piece at a time. Now you see in the second example, you have more pieces and it just got a little bit more elaborate, but it's still going to be the same general principle. The only thing that makes piecewise functions tricky is it has nothing to do with the equations, it has to do with the domains. So the if part of it. So we have 3 pieces in this one. Desmos can handle absolute, so we're not really worried about that. I want my x values to max out at -1 for the first piece. All right, so I only want it to go up as high as -1. So what I would do, let me just refresh this. Type in y equals 2x minus 3. Good looking graph. If you can pull the coordinates off the graph, that's fine. Otherwise, gear icon, table icon. I only want it to go as high as -1 for x with an open circle. All right. So we have a less than symbol here. So that means that we're going to get an open circle at the x value of -1. Same deal for the +2, open circle. Right. So here I have a -2, I have a -1, that's fine. That it's a line, so that should actually be enough for me to create the graph. But maybe it's not enough. let me get a -3 in there. So I'll type that in manually. It tells me -3 is -9. That's going to go off the grid anyway. So I'm actually going to disregard that. So -2, 7, -2, -7, -1, -5. Remember, when you draw a line, all you need are 2 points and a straight edge. It's when you're plotting other types of functions, you probably need more, you know. So the second piece is going from -1 to 2. -1, 0, 1, 2. I could just write that in. So y equals absolute, right next to the comma is your absolute symbol. X, close up your absolute, -5. Good looking V-shaped graph. Convert it over to a table. Again, all I need is -1 to 2. So -4, -5, -4, -3. And then the last one, we know that it has to be greater than 2. So we'll start our table at 2 and throw in a couple more points. So y equals x squared. Again, convert it over to a table. So starting at 2, we know we're going to get a 4. That's not really enough. So let me put in the 3, you know, the 4, you know, like now it's kind of getting out of hand, but that's okay. I'll put it down on paper anyway. But we're not going to plot all those points because it's going to go off the grid, and we don't want to scale it just for a couple of points. All right. So first thing I noticed for the line, I have a -7 here. So I want to make sure I give myself enough room for that. So I'll plot it a little on the high side. All right, so -2, -7, 1, 2, 3, 4, 5, 6, 7. -1, -5. Oh, and that's going with an open circle. All right. Now, this first piece is all value or has all values of x less than -1. So that means it could be -2, -3, -4, -infinity. So we allow for this to go on forever. So we throw an arrow on it. And that piece is accounted for. So this is done. The next piece starts at -1, -4. Goes to 0, -5. 1, -4, and 2, -3. Connect the dots. Having your calculator handy is a good idea because if you didn't know what the graph was supposed to look like in its full-blown form, then you're probably not going to know too much about what it would look like in its truncated form. Right? So we want to be careful about that. The last one, 3, 9, that's going to be tough, but 2, 4 I can plot. Open circle. Now, what I'm about to do may seem to like violate every rule of graphing, but I'm going to show you how it works. Right? So instead of scaling your graph just to plot one point, what we'll do is we'll plot it off the grid, at least temporarily. So I need to go to 3, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That would put a point right there. All right. We know what the shape looks like because it's on Desmos here. All right. So if I follow this graph, oh, well, I just closed out the wrong one. So let me just type it in again. Y equals x squared. If I follow this graph point-wise, we know that from 2 to 3, we're living in this neighborhood. It's pretty steep, but it does have a curve to it. All right. So if I were to draw the entire parabola, it would look something like this. Well, poor quality. That's what it would look like. You know, in a sense, my shaky handwriting notwithstanding, right? So what I would want to do is just draw that bit of it to give it a little bit of a curve, but then get rid of this, right? So instead of erasing it and getting rid of all the evidence, what I would say is erase this and throw an arrow onto this, all right? So you look at it and say, well, isn't that just a line? The erasure is what's showing the attempt to actually create the correct shape. Now, this may not be the best example ever for that idea, just because it's not very curvy at that location. It's starting to get really steep, but you get the idea, hopefully, that if the domain on this one were, instead of greater than 2, let's say it was greater than 0, you would draw something like this, go off the page and just get rid of everything, but then at least you'd have the shape to it. All right. Now, very quickly, I'm going to show you Desmos, the Desmos approach for creating a piecewise function. It's not something that everybody's going to like, because it doesn't really look too much like what we just did, but I'd be remiss if I didn't show the tech approach also, right? So if you have a given piecewise function, what you would do is type in each piece separately, just like we did. But then what you would do afterwards is what probably would annoy people the most. You open a squiggly bracket, and then you just type in your domain, just as you see on paper. So you would type in x less than -1. Then you could close the squiggly or not, it doesn't matter, it'll close it for you anyway. All right. So 2x minus 1, I'm sorry, 2x minus 3, where x is less than -1. And so it'll plot that piece. All right. The issue that we run into here, and this is a big deterrent for a lot of people, they're like, well, I'm not going to do it this way, is it doesn't show, it doesn't permanently show you the open circle. You have to plot that. But you can drag, if you type it in like this, you can drag along the curve, or in this case, the line, to the endpoint, and it'll tell you whether it's supposed to be an open circle or not. And then you can just plot it by hand. All right. So I know now that at -1, -5, I'm supposed to have an open circle. So what I'll do is I'll type in -1, -5. I'll make it the same color just to be particular, and then open circle. All right. So again, I'll do that again. So type in the coordinate -1, -5. Long press on the point, the green dot. Change the color and change it from solid point to open circle. All right. So that would be that piece. The second piece, again, type in the equation, y equals absolute x, close it up, -5. Open your squiggly bracket. So in your keyboard, open a squiggly bracket, and then just type in the given domain, -1 to 2. So -1 less than or equal to x, less than or equal to 2. And it'll plot that piece for you. All right. We don't need to put like endpoints on it. It's already there. The last piece, y equals x squared. Open your squiggly bracket, x greater than 2. The issue again, if you drag along, you'll see that it's supposed to be an open circle at the end. Whereas for the absolutes, you drag along, it's a solid point. All right. So I need to plot this point here, which appears to be at 2, 4. So 2, 4, long press, black, open circle. And now we have our piecewise graph. The only thing that Desmos won't do is arrows. but that's okay, because if you have an appropriate piecewise Desmos graph, if you zoom out, you get the idea that it goes on forever pretty easily. Right? You just keep zooming out and it never stops. So that part nobody will ever be worried about. All right. But that would be another quote unquote by hand way of doing a piecewise graph. So on a test, you could do it this way as well. All right. So if you want to do it on Desmos, or if you want to do it like literally by hand, that's fine too. But we will need to be able to construct graphs, right, in pieces. Right. So that's pretty much that, because the next question is asking you to evaluate the piecewise function. So what I'm going to ask you to do is try this problem on your own, and we'll go over it next class. Once you come up with the graph, this part, these will be very easy. Right? You could also evaluate it manually, but what I want you to do is practice the graph. So graph and evaluate. All right. And there's more practice problems, but these are a little bit trickier because they go the other way on the next page. So I'm not going to assign those because you'd have to write the equation of each piece, and I wanted to take the time with that. I don't want to rush that. All right. So yeah. Anyway, that's where we're going to end it. Let me stop the recording.